Hello my dear friends, welcome to all of you. Myself, Dattu Patel, Assistant Professor from LJIT. Today's session, we are going to discuss about the new unit which is Fourier Integral. Let's see what is Fourier Integral. If function is in periodic form, then we will represent it as a Fourier series which is already learned in last semester. If given function which is not in periodic form, or we can say that it is non-periodic function, then it will represent as a integral form. It is known as Fourier integral. Let f of x be a function which is piecewise continuous in every finite interval in minus infinite to infinite, or we can say that absolutely integrable in minus infinite to infinite. Fourier integral of the given function is represented by f of x equal to integral 0 to infinite a of omega cos omega x plus b of omega sin omega x d omega, where a omega equal to 1 upon pi integral minus infinite to infinite f of x cos omega x dx, and b of omega is equal to 1 upon pi integral minus infinite to infinite f of x sin omega x dx. See, what we have to do such kind of examples, just finding the values of a omega and b omega and substitute the values of a omega and b omega in this equation, then we get the Fourier integrals. Let's move on the Fourier cosine integral. Fourier cosine integral of the given function is represented by f of x equal to integral 0 to infinite a of omega cos omega x d omega, where a of omega equal to 2 by pi integral 0 to infinite f of x cos omega x dx. Let's move on to Fourier sine integral is given by f of x equal to integral 0 to infinite b of omega sin omega x d omega, where b of omega is equal to 2 by pi integral 0 to infinite f of x sin omega x dx. See, basically we have the total three methods: Fourier integral, cosine integral and sine integral. In cosine integral, we just find the values of omega. In sine integral, we just finding the values of b omega and substitute it in Fourier integral formula. Let's move on the one example. Using Fourier integral, prove that integral 0 to infinite cos omega x plus omega sin omega x upon 1 plus omega square d omega, where function is 0 where x less than 0, pi by 2 where x equal to 0, pi e raised to minus x where x greater than 0. These are the functions and we just get the answer in this form. Here sometimes you use the variable omega as well as lambda. See, basically our function is f of x equal to 0 where x less than 0, pi by 2 where x equal to 0 and pi e raised to minus x where x greater than 0. And Fourier integral is represented by f of x equal to integral 0 to infinite a of omega cos omega x plus b of omega sin omega x d omega. See, what we have to do, just finding the values of a of omega and b of omega and substitute it and give the simplification. Let's move on to finding the value of a of omega. And we have the formula a of omega is equal to 1 upon pi integral minus infinite to infinite f of x cos omega x dx, where here our limit which is in terms of piecewise continuous form, then 1 upon pi splitting the limits minus infinite to 0 f of x cos omega x dx plus 1 upon pi 0 to infinite f of x cos omega x dx. See, whenever our limit which is x less than 0, then function is equal to 0, and x greater than 0, then function which is pi e raised to minus x. Then substituting the values of function. Now first term becomes 0, 0 into anything 0, then plus this pi will be constant comes out, then pi will be cancel out. Integral of 0 to infinite e raised to minus x cos omega x. Then we have the formula integral of e raised to ax into cos bx dx. Then e raised to ax upon a square plus b square a cos bx plus b sin bx. In such kind of formula, values of a is equal to minus 1 and b equal to omega. Substituting the values of a equal to minus 1 and b equal to omega. Then e raised to minus x upon 1 minus 1 whole square plus omega square minus cos of omega x plus omega sin of omega x. Then applying the limits, upper limit minus lower limit. Then e raised to minus infinite, that is 0, 0 into anything 0, then upper limit which is 0, lower limit has a minus, e raised to 0 that is 1, then 1 upon 1 plus omega square, cos 0 1, sin 0 0, then 1 plus 0, then it is minus 1, then minus minus plus, then a of omega is equal to 1 upon 1 plus omega square. Similarly, we just finding the values of b of omega. Let's move on to b of omega is equal to 1 upon pi integral minus infinite to infinite f of x sin omega x dx. Just splitting the limits, then 1 upon pi integral minus infinite to 0. Whenever our limit which is minus infinite to 0, function becomes 0, and our integral which is 0 to infinite, function which is pi e raised to minus x. Then substituting the values of function and splitting the limits, then first term becomes 0, 0 into anything 0, this pi will be comes out, then pi will be cancel out. Then here remaining term, we have the formula e raised to ax into sin bx dx equal to e raised to ax upon a square plus b square a sin bx minus b cos bx. In such kind of formula, values of a is equal to minus 1 and b equal to omega. Then e raised to minus x upon 1 plus omega square inside the bracket minus sin omega x minus omega cos omega x. Then applying the upper limit minus lower limit, then e raised to minus infinite, that is 0, 0 into anything 0, then upper limit which is 0, lower limit has a minus, e raised to 0 that is 1, then 1 upon 1 plus omega square sin 0 0 minus cos 0 1, then 0 minus omega, that is minus omega, minus minus plus, then it becomes omega upon 1 plus omega square. Now substituting the values of a of omega and b of omega in our Fourier integral of the function is given by f of x equal to integral 0 to infinite a of omega cos omega x plus b of omega sin omega x d omega. Just substituting the values of a omega and b omega and give the simplified, then a of omega which is 1 upon 1 plus omega square, b of omega that is omega upon 1 plus omega square. Taking LCM, that will give you integral 0 to infinite cos of omega x plus omega sin of omega x upon 1 plus omega square d omega is equal to function that is 0 where x less than 0, pi by 2 where x equal to 0, and pi e raised to minus x where x greater than 0. Hence, prove whatever the given question which is proved here. Let's move on the one more example. See, find the Fourier integral represent of the function f of x equal to 1 where mod x less than 1, 0 where mod x greater than 1. Also deduce that, or also we can say that calculate the first one is 0 to infinite sin omega cos omega x by omega d of omega, and another one is a 0 to infinite sin omega by omega into d omega. See, firstly we have the function f of x equal to 1 where mod x less than 1 and 0 where mod x greater than 1. See, according to that condition we can say that if our function which is mod x less than 1, which is represented as minus 1 less than x less than 1, and mod x greater than 1 which is represented as x greater than 1 and x less than minus 1. Inside this range, function has a value 1, minus 1 to 1. If values of x which is in between minus 1 to 1, function having 1, and except that range, function having 0. Let's see firstly finding the Fourier integral, then which is represented as f of x equal to integral 0 to infinite a of omega cos omega x plus b of omega sin omega x d omega. Just finding the values of a omega, b omega and substitute it. See here our function which is 1 and 0 if mod x less than 1, if mod x greater than 1. So just we represent in terms of graphical. Then what we have to do, this one is our x-axis, then minus 1 to 1, this one is our function, this one is minus infinite up to plus infinite, then in between minus 1 to 1 function having value 1, and except this range function having value 0, means minus 1 to 1 function having value 1 and minus infinite to minus 1 function having value 0 and 1 to infinite which is also 0. Then according to this graphical representation we can say that it is even function, because suppose this one is function f of x, that according to the graphical representation f of minus x equal to f of x, f of minus x equal to f of x means whatever the values of up to 0 to minus infinite which is same as 0 to infinite, then we can say that given function is a even. That means here we can also use the cosine integral. Then if we use the cosine integral, then just finding the a of omega and substituting the b of omega directly 0. See, if you don't know given integral is a cosine integral or sine integral, then just finding the values of a of omega and b of omega both, and according to that we just get the values of b of omega which is 0 in this example. Suppose you can easily identify this one is even function, then we can say that it is cosine integral, then we substitute the directly b of omega is equal to 0. Let's see firstly finding the a of omega, then after solve the b of omega. Then a of omega is equal to 1 upon pi integral minus infinite to infinite f of x cos omega x dx. Firstly what we have to do, splitting the limits. Then according to this graphical representation 1 upon pi which is common, then minus infinite to minus 1 function having value 0, minus 1 to 1 function having value 1 and 1 to infinite function having value 0. These are the splitting the limits. Then first and last term becomes 0 because 0 into anything 0. Then middle term which has a minus 1 to 1, here cos which is even function, then multiply with 2 and splitting the limit, half of the limits means 2 by pi 0 to 1 cos omega x dx. Then integral of cos, that is sin omega x by omega, then applying the upper limits minus lower limit, then sine of omega, then whenever we apply the limit 2 by pi sine omega by omega minus sine 0 by omega. But you all are aware about the values of sine 0, that is 0, then 0 into anything 0, then twice sine omega by pi omega. Let's move on the values of b of omega. See, here b of omega is equal to 1 upon pi integral minus infinite to infinite f of x sine omega x dx. See, firstly what we have to do, obviously splitting the limits, then 1 upon pi, we have the three conditions minus infinite to minus 1, minus 1 to 1 and 1 to infinite. Then first and last limit has a function has a value 0, then 0 into anything 0, then first and last term becomes 0 and middle term which is 1 upon pi minus 1 to 1 into sine omega x dx. Now here sine which is odd function, then whenever our limit which is symmetric and it is odd function, then b of omega is equal to 0. See, here you just substitute the directly as a 0. If you don't know which is even or odd, then what we have to do, just solve this. The integral of sine, that is cos omega x upon omega, limit which is minus 1 to 1, applying the upper limit minus lower limit, then here minus pi of cos omega x, then here substituting the 1, then cos of omega minus cos of minus omega. See, cos of minus theta is equal to cos theta, then it becomes 1 upon pi of omega, here minus sign, then cos omega minus cos omega, this one will be cancelled out, then it becomes 0, then b of omega which is 0. Now substituting the values of a of omega, b of omega in Fourier integral representation. Then Fourier integral of the given function is represented by f of x equal to integral 0 to infinite a of omega cos omega x plus b of omega sin omega x d omega. Here b of omega that is 0, a of omega that is 2 sin omega upon pi omega into cos omega x d omega. Now simplified that term means this pi will becomes this side and 2 will becomes in denominator side. That will give you integral 0 to infinite sin omega cos omega x by omega d omega is equal to pi by 2 f of x. This one is our equation number 1. Here this one is our Fourier integral representation, but we also evaluating the two calculation. Let's move on the first. See, whenever our graphical representation of the function, that means here minus 1 to 1 having function 1, except this range function having value 0, but up to minus infinite to minus 1 function having value 0, 1 to infinite function having value 0, but and minus 1 to 1 function having value 1. But what about the minus 1 and what about the 1? Means exactly what is the values of the function at position minus 1 and 1. Means given function is discontinuous at 1 and minus 1 position. For that we just finding the values of function at position 1 and minus 1. For that we have the formula at x equal to 1 means f of x at x equal to 1, that will indicate by the f of 1 is equal to 1 half limit x tends to 1 minus f of x plus limit x tends to 1 plus f of x. Means function having value before the 1 and after the 1 position. Before the 1 and after the 1 position. 1 and 0, then 1 half 1 plus 0, that is 1 half. Similarly at position minus 1 means before the minus 1 and after the minus 1, that is f of minus 1 equal to 1 half limit x tends to 1 minus f of x plus limit x tends to 1 plus f of x. Substituting the values of before the minus 1 position and after the minus 1 position, that is 0 and 1, then 1 half 0 plus 1, that is 1 half. Means values of f of 1 and f of minus 1 which is 1 half. Now substituting this all the values in our equation number 1. Hence our equation number 1 which is integral 0 to infinite sin omega cos of omega x upon omega d of omega equal to pi by 2 f of x. See, we have the function which has the if values of x mod x less than 1 then 1, mod x greater than 1 then 0. If values of mod x less than 1 then function having value 1 then 1 into pi by 2, that is pi by 2. If function having value mod x greater than 1 has a 0 then 0 into anything 0. If values of x equal to mod x is equal to 1 means at position x equal to 1 and x equal to minus 1 function having value 1 half, that is pi by 2 into 1 half, that is pi by 4. That is our first calculation which is proved that. Secondly, substituting the x equal to 0 in equation number 1, then integral 0 to infinite sin omega into cos of 0 upon omega d of omega is equal to pi by 2 f of 0. See, here it becomes f of 0. Then according to that f of 0 has a value 1. How? Then according to the graphical representation, minus 1 to 1 at this 0 position function having value 1, then f of 0 that is 1, then 1 into pi by 2, that is pi by 2, which is prove that our second calculation. Let's move on to calculate the one more example. Example number 3, using Fourier integral, prove that integral 0 to infinite 1 minus cos of omega pi upon omega into sine of omega x d omega, where function which is pi by 2, 0 less than or equal to x less than or equal to pi, and 0 where x greater than pi. See, this one is our function, and this one is a answer which have to prove that. Then according to the question, we just finding the sine integral. How we can identify the given function which is in form of sine integral? Because our answer which is in form of sine of omega x, then it is sine integral. If here cos of omega x, then which is cosine integral. If sine omega x and cos omega x both are present, then we solve with the help of Fourier integral. See, then here with the help of Fourier sine integral, f of x equal to integral 0 to infinite b of omega sine omega x d omega. Just substituting the values of b of omega, then we just find the values of b of omega. For that we have the formula b of omega is equal to 2 by pi integral 0 to infinite f of x sine omega x dx. See, firstly what we have to do, splitting the limits, then 2 by pi integral 0 to pi function having value pi by 2 and pi to infinite function having value 0. Then second term 0 into anything 0, then second term becomes 0, then pi by 2 pi will be cancel out, 2 will be cancel out, then function becomes integral 0 to pi sine omega x dx. Then integral of sine, that is minus cos of omega x upon omega, where x which is running from 0 to pi, applying the limits, that means upper limit minus lower limit, then cos of here minus sine will be common out, cos of omega pi minus cos of 0 upon omega, then cos 0 that is 1 and minus sign comes inside, then 1 minus cos of omega pi upon omega, that is the values of b of omega. Just substituting the values of b of omega in Fourier sine integral, which is f of x equal to 0 to infinite b of omega sine omega x d omega, then it becomes integral 0 to infinite 1 minus cos of omega pi upon omega sine of omega x d omega is equal to function is equal to pi by 2, where 0 less than or equal to x less than or equal to pi, and 0 where x greater than pi. This is the answer which we have to find. Let's move to the one more example. Finding the Fourier cosine integral of function e raised to minus kx, where x greater than 0 and k greater than 0. Similarly, one more example, Fourier cosine integral of the function pi by 2 e raised to minus x, where x greater than or equal to 0. See, in both the example, what we have to do, that our interval which is 0 to infinite, here both the cases has a cosine integral, then we just find the values of a omega. Both the example we just finding the values of a omega and substitute it in our Fourier cosine integral formula. This both the example you can try as a homework. I hope you guys you learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.